In this video, we are going to focus on the chapter of binomial theorem, focusing on the skill, how do I use the general term formula to find specific terms, coefficients, and unknown values. So we will first start by analyzing what we have in our AMath formula sheet as well. This is what is given in the AMath formula sheet. And for this skill, it's important to be able to extract from this formula sheet here. In the binomial theorem formula, I know that this portion here actually is the general term formula. This general term formula is a very important formula because every term, let's say term 1, term 2, term 3, in the binomial expression can be represented by this very general form here, r. N choose r times a power n minus r times b power r. So this n, r, a, b, these are the unknowns. A, b comes from your given binomial here. N represents the power in which the binomial is raised to. And what is this r? R actually represents the position of your terms. So for example, let's say this is term 1, term 2. Okay, maybe make it clearer. This whole thing here is term 2. This whole thing here is term 3. So my r position starts from 0. So in this case over here, when term 1, r is equal to 0. Term 2, r is equal to 1. Term 3, r equals to 2. Okay, so in general, r represents the position of the terms. And this is the general term formula, which is very important. And this will help us solve questions that requires us to find specific terms, coefficients, or unknown values. So let's look at a very simple example question. Example 1. Okay, in this expansion here of x cubed minus 2 over x squared, the whole thing raised to the power 10, find the term in x power 10. So I just want to find one term. Therefore, there is no need for us to actually write out this entire expansion. If I want to be smart, I just need to know that I can use the general term formula here. Then I find out what is that term with x power 10. So by the general term formula, we can call it Tn, for example. The general term formula is n choose r, a power n minus r, b power r. So from this expansion here, whenever I see an expansion, to not make careless mistakes, I'll first identify what is my a, what is my b, and what is the n. So from this question here, I hope that you can see that my a, if I compare it to the binomial expansion here, okay, my a is simply x power 3. My b in this case is negative 2 over x squared, and the n is 10. Okay, once I identified this, especially because there's a negative sign here, your b also has a negative sign. Okay, then we won't make any careless mistakes when we simplify these terms. So my next step, I write out this in the general terms by replacing all my known values. So I know that the general term is 10, 10 choose r times a power 10 minus, a would be, we can be replaced by what we have found over here, which is x cubed power 10 minus r times b, which is negative 2 over x squared power r. Okay, and once I've obtained this general term formula, what I want to do is to actually simplify this formula such that I can obtain just a single x with a certain power over here, which means I have to combine all my x terms that you can see over here. So we can, for this question, we just need to apply what you know in your laws of indices. This is 10 choose r times x. X cubed, the whole thing power 10 minus r, we multiply them together. This will be 30 minus 3r. Okay, then over here, I have negative 2 as the numerator, power r, which can be further split into negative 1 power r times 2 power r. And the last one, this x squared is in the denominator. If I flip this upward, this will be x power negative 2. And multiplying it to this power here, this will be simply x power negative 2r. Okay, then from here, I just need to combine all the x terms together by multiplying them, and by laws of indices, if I multiply two terms with the same base, I add the powers together. This will be simply 10 choose r times negative 1 power r times 2 power r times x 30 minus 3r minus away 2r, because I add them together, this will become 30 minus 5r. Okay, and therefore I found the general term of any term in this expansion here. Now I want to find the term with x power 10. So for x to be power 10, I noticed from the general term formula is that I want this power here to be 10. So therefore, when 30 minus 5r is equal to 10, now I can solve for r, which is the position of the term, such that the x power is equal to 10. So therefore, by solving for r, we know that 5r is equal to 20, r will be equal to 4. That means that when the position of the term is 4, I know that that term will give me the power of x to be 10. So therefore, from here, if my position of r is equal to 4, my term number will be, therefore, I'm finding for term number 5. Then I replace all this r over here with 4. So therefore, term number 5 will be simply 10 choose 4 times negative 1 power 4 times 2 power 4 times x power 30 minus 5r, which we know that this will be 30 minus 20, which will be 10. And therefore, I can use our calculator to simplify this. 10 choose 4 times 10 choose 4 in this case over here will give me 210 times negative 1, the whole thing power 4, it will become a positive number, and 2 power 4 is simply 16 times x power 10. Therefore, my final answer to this question is simply 3360 x power 10. And with that, I have found the term with x power 10 by using just the general term formula directly to find what is the position of the term, and therefore using this position number r to find out what is this exact term, term number 5, which has the power of x to be equals to 10. So using the same concept, you would be able to apply this to find any term in the expansion based on whatever power that you are required to find. Yep, so that will be the end of this skill video of how do we find any specific term using the general term formula that is given to us in the formula sheet.